In this video, I will show you how to solve rational inequalities. So without further ado, let's do this topic. So for today's video, I am here to give new knowledge to my dear classmates. Okay, so our lesson is all about solving rational inequalities. But first, what is rational inequalities? A rational inequality is an inequality that contains a rational expression, where a rational expression is a ratio of two polynomials. That is, a rational expression is of the former xqx, where x and x are polynomials and x is not zero. The general form of a rational inequality has a rational expression on the left-hand side of the inequality and a zero on the right-hand side of the inequality. And now, we have a series of steps to be followed, so that we can better understand how to solve rational inequalities. So we have here our example number 1.
So 2x over x plus 1 is greater than or equal to 1. So our step 1 is to rewrite the inequality as a single rational expression. So 2x over x plus 1 greater than or equal to 1, we will rewrite the inequality with 0 on one side. So it is 2x over x plus 1 negative 1 is greater than or equal to 0. So from positive 1 turns to negative 1. So to be able to get this fraction, get the LCD, which is x plus 1 LCD divided by the denominator, which is 1 multiplied by 2x, which is 2x also. Simplify this, so it will be x minus 1 over x plus 1 is greater than or equal to 0. So, this is the fraction or rational inequality that we've made in our step number 1. Step 2. Locate the x values for which the rational expression is 0 or undefined. Factoring the numerator and denominator is a useful strategy. The rational expression will be 0 for x is equal to positive 1 and undefined for x is equal to negative 1. The value of x equal to positive 1 is included, while x equal to negative 1 is not. Step 3. Let's plot it on the number line. We have here 0, negative 1, negative 2, positive 1, and positive 2. And by the way, this is negative infinity and this is the positive infinity. Our solution is x equal to positive 1, so it is shaded. Why? Because x equal to positive 1, obviously 1 is greater than 0, and about x equal to negative 1, obviously 1 is less than 0, so that is unshaded. And our criteria needs a greater than or equal to 0. Step 4. Our next step is we'll assign a value of x that satisfies our rational expression, then solving our rational equation whether it satisfies or not. Our first column should be x less than negative 1. Our second column is in between negative 1 and 1. And our last column is x is greater than 1. So in the first column, x is equal to negative 2. Let's change negative 2 to the value of x. So our fraction now is negative 2 minus 1 over negative 2 plus 1 greater than or equal to 0. Negative 2 minus negative 1 is equal to negative 3 over negative 1. Negative 3 divided by negative 1 is equal to 3 greater than or equal to 0. Since 3 is greater than 0, this solution is satisfied. So in the second column, x equal to 0, let's change 0 to the value of x. So our fraction now is 0, negative 1 over 0, positive 1, greater than or equal to 0. 0 minus 1 is negative 1, and 0, positive 1 is positive 1. Negative 1 divided by positive 1 is equal to negative 1 greater than or equal to 0. Since negative 1 is less than 0, it is not satisfied. So in the third column, x equal to 2, let's change 2 to the value of x. So our fraction now is 2 minus 1 over 2 plus 1 greater than or equal to 0. So 2 negative 1 is equal to 1 and 2 positive 1 is equal to 3. Greater than or equal to 0. Since 1/3 is obviously greater than 0, our solution is satisfied.
Step number 5 is to summarize the intervals containing the solutions. So our final answer is x less than negative 1 and x greater than 1.